In this video, we're going to bring all of our knowledge on recurrence relations together and just look at some problems in context. Now, we've already actually been looking at problems in context as we've gone through this topic, so none of this should be that new. I suppose it's just another example for you to have in your notes jotter for reference for revision. So, the example then, a bank has a sales drive in order to attract new customers. Every 6-month period, the bank estimates that it loses 1.7% of its customers to competitors, but attracts 8,000 new customers. It has 500,000 customers at the start of its sales drive. Part A asks how many customers will the bank have in 4 years. Part B, what will happen to the number of customers in the long term if the current sales drive continues. And Part C, how many new customers would the bank have to attract in each 6-month period to maintain 0.5 million customers? So let's firstly look at Part A, because there was a lot of many parts to that question there. So reversing back to Part A then, how many customers will the bank have in 4 years? So the first step that we need to take is setting up a recurrence relation, because we don't currently have that. So UN plus 1 is equal to 0.983 UN, and that's because it loses 1.7% of its customers, so that leaves 98.3%, which as a decimal is 0.983. But it attracts 8,000 new customers. So we can see those 8,000 new customers here, and we're adding that on to the recurrence relation. The initial number of customers is 500,000. It says that that's at the start of its sales drive, and we know that in order to define a recurrence relation, we need an initial value. So that is U0 equal to 5,000. And we want to know how many customers will the bank have in 4 years. So we know that U0 is 500,000. U1, so we take our recurrence relation, substitute U0 in. So 0.983 multiplied by 500,000 plus 8,000 is 499,500. Do the same for U2, U3 and U4. Now you'll notice for U4 we do get a decimal here, but we have to round down because we can't get 0.4245 of a customer. That doesn't make sense. So our final answer is 498,050 customers. Part B. What will happen to the number of customers in the long term if the current sales drive continues? So the key thing here is that it's mentioned the long term. So the long term is obviously implying that we need to calculate a limit. So remember, the first mark when calculating a limit always comes from our statement, limit exists as recurrence relation is linear, and the value for A, which here is 0.983, lies between -1 and 1. Our formula for our limit, B over 1 minus A, so that's 8,000 over 1 minus 0.983. And putting that into our calculator gives us 470,588.2353 customers. Obviously, as you know, we can't get 0.2353 of a customer, so that is the same as 470,588 customers. Now, Part C we've maybe not really seen before. In Part C and B, we'd already done questions like that. So Part C, how many new customers would the bank have to attract in each 6-month period to maintain 0.5 million customers? So we're thinking about the number of customers the bank would have to attract. Now if we go back to the original question, it attracted 8,000. We're now maybe looking to change that 8,000, and the bank wants to maintain 500,000 customers. Now that word maintain If you think when we first looked at limits and we saw the graphs when a recurrence relation was converging to a limit, that was almost like maintenance, because you could see that straight line starting to happen. So that means that our limit here would need to be 0.5 million. And like I said, we're looking to attract customers. That was 8,000, which was our value for B, and we now want to find out what that is. So it's actually a limit question, but it's working backwards. So the limit here is 0.5 million. We want to find out how many new customers we have to attract, and we're still assuming that we're losing 1.7% of customers in every 6-month period. So it's question mark over 1 minus 0.983. So that is the same as 500,000 being equal to question mark over 0.017. If we multiply both sides of the equation by 0.017, we then get that the question mark is equal to 8,500 customers. And I suppose we can think about our answer here. Is our answer plausible? So if we think about when we were only attracting 8,000 customers, the limit was 470,000 and a half approximately. For here, we have 8,500 customers, which is obviously more, so we would expect our limit to be more, which it is. So 500,000 is bigger than 470,588. So hopefully our answer makes numerical sense here. So it would be a good idea, before the screen goes blank, to pause the video and take down this example.